Hello students. Now let's understand deletion in the beginning in the linked list. Now if I want to delete this node from the linked list, basically it's just an updation of a start node. So deletion in the beginning is again a very easy process. There is no traversing as such because we have to deal with the very first node. Now if you see if I want to delete this node, so my start node should point to this node, right? But how do I get access to this node? So this node's address is present in this node, which is the starting node. So the starting node itself has the address to the node, which will become the first node after deletion of this. So let's understand this process again. Now here, let's understand the process. When we say there was some correction in the previous code. When deletion is happening, we actually don't need this other step because it is done only when we require new nodes from the heap memory. So right now, I will just delete this part. So this is 4 and 5. So if you see here, we are just assigning a pointer and we traverse and then we delete. So that was the earlier case where we want to delete the node from the end side. Now we want to delete from the beginning of the linked list. So I want to delete this node. So a simple process is you just have to update the link of start. So I can directly say, like I can say step 1, which is start equals to. Now, how do I get the address of this node? So what is the name of this node? It is nothing but start. So the start is pointing this node. So start arrow data is having 4 and start arrow next is having the address of the next node. So if I want to update start, I can take the address from start arrow next and put it in start. So I can just say start arrow next. That's it. Now this is a simple thing that you have to do while deleting. But before you delete any node, you also need to free the node, right? So if I directly update the start address, I will not have access to this because this link has been gone, right? This link has gone. So now I cannot have access to this node. And you can see that this node is still pointing to this node because this link has not been deleted. So rather than doing this, what we do is, so in this case, before this step, you can use one pointer PTR. So I will say set PTR equals to start. So whichever node I have to delete, I will take it in PTR. And then in step 2, what I will do is I will update the start pointer. So now this pointer is PTR and this pointer has been updated to point to this node. Now I have to free this node. So what I will say, step 3, I'll just free the pointer, so it's free PTR. But before freeing it, you have to make sure that you are deleting that link to the next node also. So I'll say PTR arrow next equals to null. Right? This will make sure that the link, which is the dangling pointer, I am deleting that. So this link is deleted now because this is null. And now I can simply free the node. So rather than directly updating the node, you first have to be careful that whether you have taken care of the node that you have deleted. So deletion has only 4 steps. You take a pointer PTR and assign the address of start to PTR so that PTR points to that first node. Then you update the start so that it points to the next. How did you update the pointer? By giving start arrow next address to start. And then we will make PTR arrow next as null and then we will free the pointer. So this is how we delete the node from the beginning. It is most simplest to be put in the link, single linked list concept.